This is section 4.5, Systems of Linear Equations and Problem Solving. So that means we're going to be solving the kinds of word problems where there are two unknown things that we're trying to find, and we're going to be able to come up with two equations, so a system of two equations involving two unknowns, and then we can use whatever method seems easiest to solve the system of equations and find those two things that we're trying to find. So let's go straight to some examples. Last week, Jada worked 5 more hours than Kayla. Together, they worked a total of 47 hours. How many hours did each one work? So whenever I have a word problem that I have to solve, I always like to start by focusing on what is it that I'm trying to find here. So what two things are we supposed to find? Well, there's the question. How many hours did each one work? So the two things are how many hours Jada worked and how many hours Kayla worked. So we can let X stand for one of those things and Y stand for the other one. So it's a good idea to write down what your variables stand for, especially if it's not obvious just from looking at them. So X is going to stand for the number of hours that Jada worked, and Y is going to stand for the number of hours Kayla worked. And one of the things that we know about those numbers is that Jada worked 5 more hours than Kayla. Can we translate that into an equation? If you can't see how to do that right away, it might help to think of what actual numbers might work. For example, maybe Jada worked 15 hours and Kayla worked 10. That would be one way this could be true, that Jada worked 5 more hours than Kayla. So those probably won't turn out to be the exactly right numbers, but this number has to be 5 more than this number. So the number of hours Jada worked, that's X, has to be equal to Y plus 10. Plus 5. So that's one equation. Jada, the number of hours Jada worked, is 5 added to the number of hours that Kayla worked. Okay, what about the other equation? Together, they worked a total of 47 hours. Together, okay, that means if we add X plus Y, that should equal 47. Like, for example, maybe Jada worked 20 and Kayla worked 27. That doesn't fit everything in the problem, but it does fit that particular condition. 20 plus 27 equals 47. Okay, now we've got our two equations. We're going to put them together and solve the system. And since one of these is already solved for X, it says X equals Y plus 5, seems like a good idea to do substitution, to substitute that in place of X in the other equation. So if I do that, it says Y plus 5 plus Y equals 47. Combining like terms, 2Y plus 5 equals 47. Then subtract 5 on both sides, 2Y equals 42. Divide both sides by 2, Y equals 21. And then what about X? Well, now that we have this number for Y, put it in place of Y, and we get X equals 21 plus 5, so X equals 26. Now, before we declare ourselves done with the problem, we need to make sure that we've carefully answered what it is they were asking. They were asking how many hours did each one work, so we need to make sure we clearly answer that question. So the answer is, remember what our variables stood for. Now we have numbers for those, and we can say that Jada worked 26 hours and Kayla worked 21 hours. Let's try another one. Zelda has 20 coins. Some of them are dimes and the rest are quarters. If she has $2.90, How many of each kind of coin does she have? Okay, what two things are we supposed to find in this problem? How many of each kind of coin does she have? So if we break that down into two separate things, one of those things is how many dimes she has, and the other one is how many quarters. Okay, let's let D stand for the number of dimes, and Q can stand for the number of quarters. Now we need to come up with two separate equations that both have D and Q in them. One of them comes from there's 20 coins. So maybe there's 10 dimes and 10 quarters. Maybe there's 15 dimes and 5 quarters. Maybe there's 1 dime and 19 quarters. But these two numbers have to add up to 20. So D plus Q equals 20. And the other thing we know is that she has $2.90. So that's how much this is all worth. Now you do have to know that dimes are worth 10 cents each, and quarters are worth 25 cents each. So like if she had 9 dimes, that would be 90 cents worth of dimes. If she had 8 quarters, that would be worth $2 worth of quarters, and that would add up to $2.90. It wouldn't be 20 coins, so that's not the correct final answer, but it is one way of having the right amount of money. So whatever D and Q turn out to be, 10 cents for each dime plus 25 cents for each quarter has to equal $2.90. So now we have our two equations. D plus Q equals 20, and 0.10D plus 0.25Q equals 2.90. We could solve this system either by substitution or by addition. And I think it's about equally easy either way. I'm going to do it by the addition method. And what I'm going to do is I'm going to take the top equation and multiply by -10 to get a -10D here. And then the bottom equation, I'm going to multiply by 100, and that will get the decimal points out of the way. Because when you multiply by 100, you move the decimal point 2 places to the right, and that turns that bottom equation into just plain old 10D plus 25Q equals 290. So -10D minus 10Q equals -200. Positive 10D plus 25Q equals 290. When I add the two equations together, the -10D and the positive 10D kill each other off. The -10Q and the positive 25Q add up to 15Q. And -200 plus 290 equals 90. So now we're looking at 15Q equals 90. Divide both sides by 15, and we get Q equals 6. 90 divided by 15 is 6. And then come back here and put 6 in place of Q. D plus 6 equals 20. Subtract 6 on both sides. D equals 14. So now that we have numbers for both of our variables, remember what they stand for, we can specify, okay, here's the answer to the question. How many of each kind of coin does she have? Well, she has 14 dimes and 6 quarters. Next example. If 4 hot dogs and 2 hamburgers cost $15 and 3 hot dogs and 1 hamburger cost $9.50, what is the price of hamburgers and hot dogs? Okay, so what two things are we supposed to find here? What is the price of hamburgers and hot dogs? So one of the things we have to find is the price of hamburgers, how much each hamburger costs. And the other thing we have to find is the price of hot dogs, how much each hot dog costs. So let's set up our variables. Let's let maybe H stand for the hamburger price and H stands for hot dog. Wait a minute. That's not going to work. We can't use H for both of them. I mean, they both start with H, but yeah. Maybe how about B for burgers and D for dogs? And if those look too much alike, you could just use X and Y. But I'll go ahead and use B for the burger price and D for the dog price. So each hamburger costs B, whatever that is, and each hot dog costs D dollars, whatever that turns out to be. Now we need to come up with two equations. 4 hot dogs, and D is the price of each one of those, and 2 hamburgers, B is the price of each one of those, cost $15. So 4D plus 2B equals $15. And 3 hot dogs and 1 hamburger cost $9.50. 3D plus B equals $9.50. And there's different ways we could solve this. I decided to use the addition method and eliminate the B's. So to go with the plus B in the top equation, I would like a minus B in the bottom equation. So I'm going to take that second equation and multiply by -2. The top equation is fine the way it is. The bottom equation, everything on both sides gets multiplied by -2. And now we have still 4D plus 2B equals 15 on top, and -6D minus 2B equals -$19 on the bottom. Add the two equations together, and we get -2D equals -$4. Divide both sides by -2, and we get D equals +2. -4 divided by -2 gave us +2. Now take that 2 and put it in place of D in either one of these equations. The bottom one maybe looks simplest, so 3 times 2 plus B equals 950. 6 plus B equals 950. Subtract 6 on both sides. B equals 350. So we have numbers for D and B. All that's left to do is to spell out exactly what it is that is the answer to this question. What is the price of hamburgers and hot dogs? Well, I'm glad you asked. Hamburgers cost $3.50. Hot dogs cost $2. I'm going to do one more example, but I'm going to end this video here and save that for the next video, just because this video is starting to run a little long. So one more example about the daily charge and the mileage charge for a vehicle rental.